So my last example here for section 3.3 is actually straight out of your textbook. This is on page 196. It's a word problem. So you can pause this and read the word problem if you want to. But essentially what this problem is asking you to do is to imagine throwing a stone, in this case a projectile, into the air, and this projectile follows this quadratic function, the path of a parabola basically. Okay. Now for some reason the textbook uses an S for height and T represents your time. So you need to use your imagination a little bit. Here's you on the ground, and you throw something in the air and it comes back down to the ground. And so what this problem is asking you to do is to find the time it takes. Here's how it's worded. It says determine the time at which the stone reaches its maximum height and then find the maximum height. So you're being asked to find how much time does it take to reach that highest point, the peak, and then how high is it at that point. Okay, well, another way of saying that is to ask you to find the vertex. It doesn't say the word vertex in the problem, but the key is it does ask you to find the maximum. The max is another word for vertex. So we're just going to go back and use our little formula, negative b over 2a, and calculate our vertex. So that's going to give us 60 over 32. 60 divided by 32 is 1.875. Now I used x there. You know, the problem is using t for time, obviously. So 1.875 seconds is one of the answers. But the other question, it says, and then find the maximum height. Well, to find height, we need to plug that value back into our original function. So our original function was negative 16t squared. Well, we just figured out t plus 60t plus 30. So this is again one just for your calculator. You type it in properly, you should get the right answer. I would type it in just like I wrote it there, and it should be fine. So the height of our projectile is 86.25 feet. It took 1.875 seconds to reach that maximum height.